Let's take a look at some exponent rules where the exponents are fractions, or they have a different look that can be converted into a fractional exponent. Exponents are not always integers, and so you can have fractions that look like this, that have a 1, so a unit fraction, a 1 over a number. They can also be any two numbers, numerator and denominator. But these two expressions here are also can be written as expressions with exponents who are not integers. So let's go ahead and do some conversions. First, let's convert these to radical form. When you do that, we get to keep what's inside. That's going to be the x. And then the root is a square root. That's what's here. You can't see a 2. I'll go ahead and put it there so you know it's there. And the 1 is here. Now, this can, and we do write this like this, just square root of x. But so that you know, the 1, or this numerator, comes from the power on the inside. And the 2 is the index of the root. That's the denominator. Let's go ahead and do that again. So the base is a. The denominator is the index of the root. And the numerator is the power of what's inside. When you look at the next one, we want to go now the other direction and write this as an exponent. This square root has a 2. Each of these powers inside are just a 1, so each of these are raised to the 1/2. And since what's inside both have the same power, and we just take those powers with us, if they had different powers, and I'll do one so that you can see what happens if it's a different power, and you get 1 over 2. If, by chance, what's inside looked like this, then you would get, and this, remember, is a square root, ab squared to the 1/2. But then we could simplify that to get a to the 1/2, and this 2 multiplies with this 1/2 to give you 1, so you get a to the 1/2 b. We'll do more of that on the next page. Then this last one, xy is what's inside, both to the first power, and the index of the root is a 3. So you should practice going back and forth from exponent to radical and from radical to exponent. Now let's do some combining here. So for the first one, we know when we have like bases, we add the exponents. That's one of our basic exponent rules. So this becomes x raised to the 1/2 plus 3/2. Add them together, you get 4 over 2, which is just 2. So this is really x squared. For the next one, we use the power rule, the basic superpower. So when it's on the outside of the parentheses, you multiply it in to that exponent. So you get a to the 2/3 times negative 1/2. That exponent can be simplified. These 2's divide out to give you then a to the negative 1/3. Now, tomato, tomato, do you leave it like this? Do you turn it into a radical? Well, it depends on what you're trying to do with it. This has a negative exponent, so that's really 1 over a to the 1/3. 1/3 is a cube root, so this is really 1 over the cube root of a. But typically, we just leave it like this when we're simplifying it. Now we've got a fraction. Let's go ahead and rewrite that numerator. You get ab to the 1/2. That comes from the previous work we just did. Let's go ahead and, power rule, multiply that exponent into each of those bases inside in the numerator. So you get a to the 1/2, b to the 1/2, over a squared b. Now you can use your exponent rules that say we can divide out. A lot of people use the slice and dice method and say that we have 2 here for an exponent. Here we have a 1/2. So down here we have 1 1/2 for the exponent, which is 3/2. Let me go ahead and rewrite that. A to the 3/2. And then for the b, 1/2 in here, 1/2 in here. And so you get b to the 1/2. And 1 because both of the numerator ones divided out. Now some people go ahead and use the subtraction rule where there's, say, 1/2 minus 2 to get negative 1/2, and then 1/2 minus 1, which will be b to the negative 1/2. So both of these could be rewritten as in the numerator. Remember, when you move them in a fraction, you change the sign. And so we can write it either as this or as this. They are both correct. It depends on what you're trying to use it for. Now for the last piece, we've got a radical sitting here. We have exponents. Let's go ahead and rewrite this first expression. That's going to be x to the 1/3, y to the 1/3, 1 because each of the exponents inside is 1, 3 because that's the index of the root. And then that's times x cubed, y to the 4th, z. We are going to use our exponent addition rule, so we have two x's. So that's x to the 3 plus 1/3. 3 plus 1/3 gives us 9, 10 over 3. Just looks better than a mixed number in the exponent. For y's, we have a 1/3 and 4, and so that gives y to the 4 1/3. So 12 plus 1 is 13, 13 over 3. And the z, there's only one of them. Sure, it looks ugly, but we are able to do more with these particular pieces once they've been simplified by combining exponents of like terms. This on the left is not simplified because you have more than one of each base, and so you have 2 of the x's, 2 of the y's, so you've got to combine them. Here it's not because you've got bases in the numerator and denominator. So what you're looking for within any particular expression, look at all the variables, and you should only have one a when you're done and one of the b when you're done. Of course, unless they divide out, then it is gone. Here you only want a single x. So that's how you know what you're going for when you're simplifying. I wish I could say there's a hard and fast rule here where you always write it like this, or you always write it in a fraction. Particularly for me, I write them like this, but for many this is not incorrect. For this one, don't write them as mixed numbers. That's really middle school. And so instead we write them here as fractions. So that's it. Hope you're having a great day.